Lawrence Ortner. I'm Warner Electric's Technical Support Manager, and this is the last of 3 videos of the companion videos to the Logix 5000 intro class. This video covers the labs that we do in the class that deal with branches, timers, and documentation. First, I want to create a couple of rungs in my controller that use branches. So I'm going to switch back over to my bit logic routine and add those rungs in. Of course, there's multiple ways to add rungs into the logic. I'm going to use a little combination of click and drag as well as typing in mnemonics by typing in 3-letter abbreviations for each instruction and then adding the tags to them. So you can see I've started with a basic rung of logic that has an input and an output on it, but now I'm going to add a branch to that. And I typically add a branch by dropping the branch start on the left side of where I want the branch to surround, and then drag the right side to the proper location. I can then add an instruction to that branch, again by typing in a mnemonic. I typed in XIC, and we get a normally open instruction, and I can add a tag to that, for example, DI5. Now in this case, I want that branch to extend down one more time, but rather than adding a new branch, I can simply right-click on it and add a branch level. And again, I'm going to put a normally open instruction on there by typing XIC and adding a tag to it, DI6. So you can see adding branches to a rung is pretty quick. I'm going to show another rung though that's slightly different. And again, I'm going to use mnemonics to make this process go a little bit faster. You can see by typing XIC with spaces in between and an OTE at the end, I've already gotten 3 normally open instructions and an output coil. I'm going to throw in a couple of branches here, and you can see I can choose where to throw those branches starting in and where they end. I'm going to put another branch in, and I guess I would call this a nested branch where one branch is inside of another. And in some cases, the logic that you need to put in requires a nested branch as opposed to simply an extended branch. In this case, again, I can click on the corner and type in the mnemonic for the instruction. Here I wanted a normally closed instruction rather than a normally open. And here, just to show the difference, I'm going to add in 2 normally open instructions. And now it's a matter of typing in the tags that we're going to use in each of these locations. And if I type it in correctly, it'll actually pop up. You'll notice that when I typed it in with the misspelling in the tag name, the software didn't recognize it and didn't show the alias information. DI12, DI14, and got a couple of others to add. You'll also notice that uppercase and lowercase are ignored, although it will hold the case the way the tag was created. And finally, on that output instruction, I have a DO7. Since these rungs have been edited while online, again, I'll need to process them by doing the finalize. These rungs are now in the controller and executing, so if I were to press, for example, DI4, digital input 4, this yellow button, that one turns green and the output goes on, but of course input 5 or input 6 also turns that output on. In the class, of course, there's much more time to practice editing the logic with branches as well as create your own logic. Now let's take a look at the timers that we have. The timers were pre-built to save a little time here. Just want to take a look at a couple of timers in the logic. For example, here on rung number 1, we've got a timer, and the name of that timer is auto timer, created by the engineer. And you can see that this timer just never seems to stop, and it's because we're using its own done bit in front. So each time the timer does get done, it resets itself and starts again. That's a fairly common practice in logic. The next rung is just a timer on delay, and you can see that's preconditioned with the input DI12, which is a toggle switch. When DI12 comes true, the rung comes true, the timer comes true, the enable bit comes true immediately. There's also a timer timing bit that's not shown here, but that timer timing bit is shown below. And we see that as the timer is accumulating time, the timer timing bit stays true, but as soon as we've reached our preset, the done bit goes on and the timer timing bit goes off. The time off instruction is similar. And the RTO instruction is a little bit different in that it actually will hold its time when the rung goes false, whereas most timers will reset themselves when the rung goes false. The retentive timer requires a reset, and you can see that in rung number 9. DI0 would reset that. Of course, every good programmer knows that the only way to understand logic is to document it. And so let me show you a couple of ways to document logic. For example, I can right-click on rung number 1, edit the rung comment, and type anything in here as well. For example, this is a rung comment, and surprisingly, I spelled all those words correctly. We can also document and put a description on each individual tag. So just as an example, I'm going to right-click on DI12, edit the properties, and here we can put in a description. This is input toggle switch 12. Obviously, in the real project, the descriptions would be much more related to the actual machine. If you have any questions about these videos or would like to sign up for one of our classes, please contact Warner Electric Supply.